Hi, good evening, everyone. We're just going live on YouTube and then we will start. Next 1 or 2 minutes, we'll be starting.
Visible.
It's visible. Yeah. So, hi guys. Today we are covering two topics. One is related to RPG indicators, and another is related to parameter passing in RPG. So, do you guys know what indicators are? Anybody has any idea on that? Hello, nothing is submute में क्या? Am I audible?
Yes, you are audible.
So, indicators are something like which indicates you you can compare it with a switch has a two states, on and off. In the same way, indicators will give you a response of yes and no, 0 and 1. So so uh, I think all of you are aware about the 0 and 1. 0 is something like no, means it's not on, and 1 is like on, it's on. So on the basis of indicator, we can means on the result of the indicators, we can perform some actions. So it has a we have in RPG we have a lot of indicators, and especially in RPG 3 only. RPG 4 is also having, but at that time we are also having some other opcodes for those things to handle that. And now in free format, mostly indicators has been omitted, thus they are appearing in means now you can see those indicators in display files and printer files only. बाकी और कहीं नजर नहीं आएंगे. Even in CL you can use that, still people use that. So it totally depends on programmer to programmer. Some tackle it with some other things, some used indicators like here, like you can see that 0 to 1 9 0 1 to 99. Oops, wait, 0 1 to 99. So this is one kind of indicator. Like you can use any of the indicator, and they are the general indicators. They are of two type, two digits number. And similarly, we have another group of indicators, that is Ka to Kn and Kp to Ky. O indicator is missing, if you notice that. So these are something which is means these are, as you can they indicate any functional keys. Functional keys, if you can see on your keyboard, you are having keys like F1, F2, F3, F4. So like this, we have F24, total 24 indicators we are having. So we can use like that on means if you want to capture response of any functional indicator, then you need to use Ka to Kn or Kp to Ky. I will explain them later in this session. Others are H1 to H9. They are known as halt indicators. So halt indicators are the things I have also never seen these indicators. Uh, and L1 to L9, they are also indicators, and we call them as control level indicators. These are something like for passing controls from from one file to another file, or on the basis of these indicators you want to perform some kind of actions. And these indicators means this L1 and L9 indicators you will see in RPG3 only. Means in the starting of these programmings, the programmers are using those kind of indicators, but nowadays we are not using it, because the reason behind that is earlier means still we have the concept of primary and secondary file, but people means people who worked earlier in this programming techniques and all, so they were using this is L1 and L9. Now we can means at that time also it's possible to do the things using the chain and read equal, but some people use these indicators. And LR indicators are the last record indicators that give you means it indicates your program that now this whenever this whole cycle C cycle will complete, you have to close each and everything and come back out. Then we have a group of indicators like OA to OG or OV. So O O indicators are basically means the indicator starting having a prefix of O is an overflow indicators, and these overflow indicators are specifically meant for printer files only, because overflow indicator comes where we are using a printer file. Then we have a group of indicators U1 to U8. Those are the external indicators, and this is an indicator which can only be used, not used. It means the values of these indicators will be set in CL program only. You cannot set or change their values in RPG, but you can use their what you can say values, whether they are on or off in your RPG. So I will show you that. And RT is a return indicator. Return and LR can be used, means these two are going to be used in your RPG and RPG LE program, and it has a basically a bit difference. When you set on LR, it will close each and everything, every file. But if you will use RT, so that program will not going to close. It will be reside in your buffer with every position. And when again the control passes back to that program, so whatever values, whatever things it has in the previous run, it will have those. And MR matching record indicator, I didn't seen practically. I have not never worked on that, but theoretically I know that, so I will give you that example also. And MR and IP cannot be switched off. There is a opcode set off. Using that you can set off, means you can change the value of an indicator, as an indicator has only two values like off and on. So using set off you can switch it off, and using set on you can switch it on. So MR and IP are the two indicators which cannot be switched off using set off operation code. And here this is the same thing which I have described you earlier, that U1 to U8 are the indicators which is defined in CL program only, and there is a opcode switch which you can use to define these indicators along with their values. So these are some of the indicators. Then here, as I told you that I have showed you that K to Kn and Kp to Ky are the indicators, functional indicators, where Ko is missing. So here are the values. If you will press an F1 indicator, then Ka, you can tackle that on and off value using a Ka indicator. Likewise, 2 for KB, and here go on the list. This is the whole list. What if you will press shift F24, then using ky indicator you can tackle its values. So this is related to this. Now here is an example of overflow indicator. Basically these indicators are defined at the position of 33 and 34. So now the positions, by the word position means, if you can see here, there is a ruler at the top. So first position is 1, 2, 3, 4, 5, 6. Likewise, it's about go to 80. In free format, it's 80. In fixed format, it's much more than that. And again, then we have comments on all that. So here is an example how we can define or use overflow indicator. So this is the position 33 and 34. If you will count here, 30, 31, 32, 33 and 34 is reserved for overflow indicators. If your device type is a printer file. So now here you can see that we are using OF, OV, OE. All the means there is not means if you will define, you can define any one of these, and even in spite of using O indicator, you can define 1 to 99 indicators, any of the indicator, and basically it will get on when your printer file got overflow. I hope you all know overflow means. Overflow in the sense like we are printing a page, and when it comes to the second page, so that indicator will get on. So that is an overflow. So you need to tackle whenever you will use a printer file, define a printer file, and if you think that the data is going to come on more than one pages, then you need to tackle this indicator. So this is a you can say this is the what you can say, it's a just f specs and f specs, sorry, f specs here. F specs prompt is something like this. So over, if you will press an F4 on this line, so you will get something similar to this screen, where you can see at this position you can define overflow indicators, OF, OV, OE, or 01, 02, 09. They are also working in this thing. So this is an example of this, and now basically this is a fixed format. Now here we are showing you two things. This is also the fixed format, but this is RPGLE. It's RPG4, and here this is an example of RPG3. So what's the difference is there? Difference is the prompt is different in RPG3 and RPG4. And here, if you will see, uh, we have used indicator star IN. IN indicates star IN indicates, and we are using an indicator. So this is also a different method to define it. This is a method to define in RPG4, and above example is from free format. So this is how we write in the free format. There are other things also which you will come to know as and when you will work with them. So this is a kind of format, and now let's come on the resulting indicators. So resulting indicators are the indicators which give you a result of an operation. Like here, just for example, we are performing a chain operation on this file with the this key, and we have added a 11 indicator. This is at high level, H high, low, equal. There are three types of indicators: high, low, and equal. So with chain, we always use a high level indicator. So if a chain is successful, if this operation is successful, then whether it's means if a chain operation is successful or not, you can identify that by the value of this indicator. If it's successful, this indicator value will be 0. If it didn't find a match, this indicator will get on. So on basis of this indicator values, either it is on and off, you want to perform some action. So below that you will be going to define those things. So this is a chain operation. It's a fixed format. Now here there is another example. This is for RPG4. This was related to RPG3 and this is for RPG4. Again, this is a chain operation, and we are using a 90 indicator at high level indicator, and on the basis of this value we will perform some action. So this is how resulting indicator work. Now we have another indicators like uh, on the base means these indicators are giving you the result of a operation, but when this operation need to be performed, we have certain indicators. We can use indicators that suppose a particular indicator is having, like here you can see, like here we are having, oops, we are having an N21. This means when indicator 21 value is 0, then only you need to perform this operation. If this if when the pointer will come at this line statement, and if that indicator 21 value is on, then program is not going to perform this indicator this statement. So this N22 21, you can, if you want that suppose means in this program we have a requirement that when this statement need to be performed only when indicator value is off. If suppose you want to add a line where you need to perform this this statement when an indicator is on, so then at that time you will remove N from this. So you will just write 21 like here, U8. This is an example. So whenever 21 is on, that that statement is going to be performed. So, and here you can use a group of indicators like so means, for example, I need a multiple indicators or you can say let's assume that I want to perform this statement when U8 is off and or U8 is on and N21 is off. So here I have written N21 and beside that I will write U8. After a space I will write U8. So that will mean either 21 is off or U8 is on. Any condition is true, perform this. Similarly, we can write AND operations also. Like we want U8 to be on and N21 to be off to perform this particular statement. Then beside this C, we will write a opcode, an opcode. So this is something like this. And as I told you that U1 to U8 are indicators, are the indicators which we can define in CL program, but we are going to use their values in RPG program. So here is an example. If you can see this F from, we have defined a file here in F front, and here we have defined U6. So this means basically this program is going to be called from a CL program, and before calling this program we will just set the switches values. So if in that calling program, in that CL program, U6 value is on, then only this program is going to open this file and perform action based on these files. Otherwise it will not open it. Like here, this statement is going to be performed only when U8 indicator is on. Then only it is going to be performed this. And U1 to U8 indicators are going to be set in the CL program only. So this is just an example, so that whenever a new code will come in front of you, you will just feel that yeah, you know that how to do that. Or maybe if you can see this kind of code, then using, at the end we will going to share some IBMi books with you, and they have each and everything in them, along with the explanation of the operation codes and opcodes and with examples. So you can write a simple code, a new code, and as I am sure that you guys already completed your debugging classes, debugging training. So write a small code, use debug and see how the things are operating. That's the best way, because we also, particularly I also don't know each and everything. But whenever a new thing come, then I used to do this technique to understand what exactly code is doing. So now here we have given means we have shown an example of L1 to L9 indicators. L1 and practically I have never worked on that, but uh, basically I know the concept of this. Not means I not worked much on these. Few times, maybe one or two program in my life I have worked on that. So basically L1 to L9, as I told you previously, that this come to play when you have defined a file in your file specs with a primary keyword. So here, if you will see P, this shows that this is the primary keyword, primary file, and in such types of code, you will never see a chain operation on this, because whenever you declare a file as a primary file, then the RPG cycle opened it automatically and start reading it one by one. That is something related to primary file concepts. So if you will come down here in iSpecs, you can see that basically this code is not aligned. I copied it somewhere on the net from the net. So here you can see I, and it's uh, IPREFC. So this is the record format of first file, 01 indicator, and here you can see it, this file is having basically two fields, state and city. For city it has used L1 indicator, and for state it has used L2 indicator. So what this mean, that when the program cycle will start reading that file, and once let's suppose in first record it will find a city like or you can say Jaipur, and the state Rajasthan. So when it start reading next records, and whenever value of any of these field get changed, so corresponding record will get on, otherwise it will get off. So once it get on, then it has defined in below lines that like L2 clear, if L2 is on, clear L2 pop, L1 is on. Basically the indicators which is defined before that any opcode, it tells means the compiler when this statement is going to be executed. And if it's after that, after the opcode, if any indicators come after the opcode, then it means it's a resulting indicator, it's showing you the result of that particular opcode. So this is a quite a example, and here you are seeing a one more thing, that this is there is a O specs. O specs, like in this particular example, here we are using a printer file, and in RPG3 or before that thing, uh, programmers use O specs to define that printer file format. Everything will be defined here. They will like today what we are doing, we are creating a dedicated printer file. So it was not like that. The opcode of printer file they also add in the program only at the bottom using O specs. So this is just an example. If you want to get a more example on that, then I think Satya and Avdhoot can help you, because I'm sure that they have worked on these things before. So this is something to related to L1 to L9. Now here is an MR matching record. This is also an example of this. So here what they have defined, see in file specs they are using one file, that is ID1. Here they have defined second file is name1, and in these both file there are two fields which are I think you can say common fields, like their length is common, same, and on these fields they have added M1 indicator. So M1 is matching record. Whenever they, and you also know, you please also note that the first file is a primary file and second file is a secondary file. So they have joined basically here. And as you have defined the primary file, so and secondary file, so program cycle is automatically open them and read a matching record of this. So when old number from first file and old number from second file matches similar, we will get a similar values in both the files, then this MR indicator will get on, and whenever this MR indicator get on, then only it is going to perform these operations. If MR value is off, means it means both the file are having different values in old number field, so at that time these statement is not going to be performed. Now here is an example of switches U1 to U8. So in CL there is a command change job, and here's the switch. You define the switches here. So you can, first of all, there is a limitation that you need to, means it's mandatory that you need to define only U1 to U8 8 indicators, and you have to define them. It doesn't matter if you just want to use one indicator, you have to define like this only. This is what you can, something mandatory, and it's fixed. So if you can see 1 2 3 4 5 6 7 8, if I will add this command in a CL program, what this mean, that all the indicators from U1 to U8 is off, because they all are off. Zero. They are all are having zero values. This means the indicators value, means after this change job command, if I will call any program and I will use values indicators in that program, so they all are having zero values. Similarly, if let's say I add the command in CL program change job switch, where U1 is on, U5 is on, U8 is on, rest all are off. So after that, if I will call a program, so in that program, if I'm using all the indicators U1 to U8, so only U1, U5, U8 values will be on, rest all are off. So the conditions which are based on these indicators will only perform when, means that's totally depends on the programmer how it's using. I hope you guys are getting it. And here is an example. Let's assume that after this job, we have called a program, and that called program is having this kind of uh, code. So here we are checking in the C prompt if star in U1 equals to on. So if this value is on, then only it's going to perform condition between this if and if. And if suppose I call this program after this, then these statements are never going to be executed, because all the switches are zero. So this is related to U1 and U8. Yeah. Now here I'm assuming that you might have seen this kind of indicators. These are the named indicators. Named indicators are just like as you have seen that in the I'm sure that you guys are taken the display file training. So in display file we are using a lot of indicators, functional indicators like F3, F5. F3 is for exit, F5 is for refresh. So we can use those indicator directly in our program, but to look them more relevant, what we are doing, we are using a named indicators. So here what we are defining, like you can see that in F specs, first of all, you need to define an INDDS, and then in INDDS, you will define that F3 means exit, F5 means refresh, 50 means you are giving those indicators the relevant name, so that or not relevant, or a meaningful name, so that any programmer which is going to read this program can understand easily, because by seeing 03, nobody can understand what it's doing. Generally you will see 03 is everybody is using for exiting a program, but let's say you are using it, but I didn't use it. I use in my program F03 is for refresh. So if I will use such kind of naming indicators, then it gives more relevant meaning to the indicators, and it will be get easy to understand for the other programmers. So like here, just an example here, you can see what we are using a do loop here, and what we have mentioned w exit equals to out. So w exit means 03 indicator. It is defined in our work file. So whenever you need to perform this do while loop, means a statement present in between this till this is off. So w underscore exit is the same as 03 indicators. So in few programs where programmer has used a named indicator, you can see this thing. Otherwise, you can also see like star in 03 equals to off. So both are the same thing. So this is something you will see in your programs. Now let's come to a calling program. So calling program is calling parameters basically. This is the topic. So calling a program performs two things. First of all, it calls a program and it passes a parameter. So if suppose in your any of the RPG or RPG LE program, you need to call a program and pass a parameter. So this is the code how you can call it. So in the call, when with the call opcode, you are going to use the name of that program, and param is the parameters which you are going to pass from this program to that program, or vice versa. Means after calling this program, maybe you are getting some parameters, some values in this program, in this program, in this parameter. So this is just an example. So for calling a program, you need to use a call and param, and the program where which you have called must have an star entry parameters. Like see here, plist star entry. So if I am calling this program, so you can see that this program has a parameter this. So when I call this, so this value is going to be passed here, and when this program performs certain operations, and when the control passed back to this program, so this value can be changed. So it's totally upon the requirement for what we are using. It's not necessary to pass the parameter. It's totally depend on the what you can say your needs or the need of the program of module what you're working on. And in here you can pass standalone fields. You can pass DS. You can pass array. So whatever you want, you can pass it, but the that structure should be matched to the called program. Means it's not like that you are passing like this field is having a 2 character, and at the receiving end you are having 5 characters or 1 character. So it will get truncated. It will give you error also. It will give you compilation error. It will not get compiled. So this is something like that. And here is an example of like in parameter. See here PRMDS. So this DS is just an example that we can pass a data structure also. And on the receiving end, we can use the data structure to receive the values as per what they want to receive. So it's an example. Now here, this is also a way to call or receive the parameters in a program. So this is an example of a free format. And here, if you can see that basically these code uh, declare PR and PI. So what this shows, this means that this program can be called by any other program and passes these parameters. So it will accept this thing. This statement shows if, because it's a fixed format, so you are not going to see any star entry parameter here. So there is a bit different in a free format and fixed format calling things. So, and like if suppose you are working in a project where customer told you that we are having a code of in fixed format, but if you are writing a new code, you can use the free format things also. So let's assume you are writing a new free format code and you need to call a program which is written in a fixed format. So now here you cannot directly use a call command to call it. So what you need to do, you need to call a you need to first of all declare a PR on this on the above what you can say declaration specs and all. So here if you want to call a program this, so you need to define it as the external PGM here, and this is basically I used to put a name here similar to the one which I am calling so that I can remember it. Otherwise you can change this one also. So whatever you will change, you need to call it here, you like using call p, and this is the way how you pass parameters in free format. So these are the two parameters which we need to pass to this program. So we are calling this procedure, and here we declare the name. So this name will come whatever you defined here, and these are the parameters. This is how you do it, and oops, and here is an example. Here is an example of how we are passing parameters to a CL program. Basically, this is a code from CL. So you might have seen that in CL we are writing PGM and NPGM. So those are mandatory when that CL is supposed to receive parameters from other programs. So at that point of time, if you are creating a CL which is going to receive, which can be called by any other program and going to receive some parameters, so you need to define it like this. PGM is the code. You can write it, press F4, and then you will get a prompt where you can write parameters, and then you need to obviously declare it below that. And calling a program in CL is simple. We are going to use call command only, but after prompt you will get the place to put a your program name which you want to call and the parameter which you need to pass. And there are other things also. It's not mandatory to pass each and everything. Means the structure maybe at the receiving end the program which you are calling having 6 parameters, but here from the program which you are calling you are passing 4 parameters only, so it's possible. So no pass was there, and basically it's totally on the design how you are creating that thing. So that kind of code you can also see somewhere. Basically this is the basic, at least if you will see the codes you will not, you will think that yeah I have seen this code, so you will not get afraid of this. So that's all from my side. If you have question and one more thing.
So if anyone have any query regarding this, then you can ask. So I guess no one have any query. So thank you for joining this session.